Good afternoon, geometry students. It is March 19th. We're going to play around here just a little bit. So I'm going to draw a triangle. Get you thinking about some triangles. I'm going to make this side here 3 inches long. I'm going to make this side here 6 inches long. And then I'm going to connect these other 2 vertices, and I'm not even going to bother measuring this third side. Okay, now I'm going to take out my compass and a straight edge, and I'm very carefully going to do some kind of a construction which you have seen before, and you should be able to tell me what I just constructed. Remember, you're not supposed to go on until you have answered that question. Anytime you see that pause, think, try sign come out, you should be thinking. Okay, so I'm going to draw in that angle bisector. And my question is, I wonder how this length right here, this segment that goes from this point to this point, compares to this segment that goes from this point to this point. Do you have any guesses? Well, you know, if I had to guess, I'm looking at that and I'm thinking that one definitely looks bigger. That one looks smaller. I'm wondering if there's a relationship between these numbers and these lengths. Looks to me like that number there is half of that, or that this number here is double that. Well, let's see what happens here. I can take this and measure off that length right there. And looky here, this one here is boom, boom. This guy here is double this guy here. So if I call this X, that's 2X. So when this leg is twice this leg, this segment is twice this segment when I chop up that third side by the angle bisector. Boy, that sounds an awful lot like a proportion. Let's try another one. Because maybe I just got lucky. Maybe I did the one triangle where that works. So, let's do this. This is going to be 5 centimeters. This side here, I'm going to make it, I'll pick any angle I want. That looks pretty good. And I'm going to make this guy here 15 centimeters. Now I'm going to connect that other side. Maybe I can be a little more accurate there. That could be a problem. Okay. I'm going to take my compass and straight edge and bisect this angle. I'm going to be very, very careful to make sure that I'm doing this with accuracy. This is something you can try at home, by the way. Okay, so my question is, how does this length right here compare to that length right there? If you looked at those numbers and had to make a guess, what would you guess? Well, if I had to guess, I'm wondering if this guy here is maybe 3 times that length there, because this is 3 times that length there. That seemed to be what happened before. Let's see if we can measure this out. From there to there, there's, okay. Let's see if this is 3 times longer. 1, 2, booyah. That looks pretty darn perfect to me, that if this is Y, this guy here is 3Y. Again, it's a proportion. It's just a proportion. So, here's what we learned. If I have any triangle at all, boom, 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 and I'd make an angle bisector, and I'm just going to guess that looks about bisected right there. Okay, so I know that this angle here is congruent to that angle there because that's an angle bisector. That the ratio of this side here to this side here is going to be equal to the ratio of this segment that's been split to this part of the segment that's been split. In other words, A is to B as C is to D. I could also write that A is to C as B is to D. All right, that's today's lesson. I'm going to give you 4 problems to try, and all you got to do is download them off of Canvas or check your Remind. Either way, you can copy them by hand, you can print it out, whatever works. Miss you guys, love you guys. Everybody be good.